What is a gear? A gear is a wheel with toothed edges that fit into one another so that they can spin each other. When one gear is spun clockwise, it rotates the other gear counterclockwise. In the middle of a gear, there is a bar or a rod that is used to turn the gear easily, saving energy. The faster a gear is spun, the less force that is being used. For example, if you have a big gear that is turning a smaller gear, the smaller gear would turn more than the big gear, but it will be using less force. Between gears, they transmit power from one part of a machine to another part of a machine. Gears can also be used to accelerate or decelerate speed in a machine, or increase the force of a machine. You can find gears in cars, like the engine of your car, in clocks, or if you've ever owned a bike, you've probably seen two gears close to the pedal, a bigger gear and a smaller gear with a chain around it. 1. The input gear has 30 teeth and the output gear has 60 teeth. The input gear revolves at 160 RPM. Find the A, speed ratio of the gears, and B, speed for the output gear. So, to find the speed ratio for the gears, what you do is you take the output gear, which is 60 teeth, and you're going to divide that by the amount of teeth that the input gear has, which is 30. And that gives us 2, which is our speed ratio. This means that the input revolves twice around the output. Now, to find the speed for the output gear, you take the speed of the input gear which they gave us, which is 160 RPM, and you divide that by the speed ratio, which was 2, that we had found for part A. And that gives us 80 RPM, which is the speed of the output gear. 2. A gear with the radius of 0.3 m is turned by a gear with a radius of 0.04 m. The moment of the smaller gear is 30 Nm. Find the moment of the larger gear. So, what you have to do first in order to find the moment of the larger gear is you need to find the force of the gears. So for that, we have the equation F equals m over r, m being moment, r being the radius, and F being the force. So we can take the moment of the smaller gear, which is 30 n of m, and divide it by its radius, which is 0.04. F is equal to 750 n. With that, we can take the same formula that we just used and turn it to be m equals Fr. And now we can plug in the values that we have found and that we were already given to find the moment of the larger gear. So we take 750 n and we multiply it by 0.3, which gives us 225 n of m, which is the moment of the larger gear. The website EDU Media has a gear simulation where you can choose a few options for the amount of teeth each gear has, and it tells you the speed ratio between them both. So if I choose the orange gear to have 10 teeth and the blue gear to have 30 teeth, then it shows that the orange gear rotates 3 times for every 1 time the blue gear rotates. Recap. What are gears? Gears are wheels with toothed edges that fit into one another so that they can turn each other. How do they work? In the middle of a gear, there is a bar or a rod that is used to turn the gear. This makes moving the gears easier and uses less energy. The faster a gear is spun, the less force it uses. When a gear is spun clockwise, the other gear is spun counterclockwise. What do they do? Gears transmit power between one another from one part of a machine to another part of a machine to either accelerate or decelerate speed or increase the force. Where are they used? Gears can be found in car engines, clocks, bicycles, drills, manual can openers, and many other machines. Sources: